All right, let's build on the previous notes where we learned about sine, cosine, and tangent with the inverse of those functions. So let's first of all just quickly recap. Let's remember our trigonometry function, sine, cosine, and tangent, and we can use the mnemonic SOHCAHTOA to remember their ratios. So the first part, SO, tells us that the sine of theta is equal to the opposite over the hypotenuse. The side opposite from the angle, the reference angle, over the hypotenuse of the triangle. The middle part, ka, we're talking about cosine. The cosine of theta is equal to the adjacent side to the reference angle over the hypotenuse. And lastly, our tangent for TOA. Tangent of theta is equal to the opposite side over the adjacent side. And this is all from the perspective of our reference angle theta. So let's practice what we learned last time, just once each. So here we have a right triangle. We're missing the hypotenuse. So if I have my reference angle here, 24 degrees, and I have the opposite side from it, and here's the hypotenuse, I'm going to use my sine function because it's opposite over hypotenuse, and that's what I have here. So the sine of 24 is equal to, and again, it's opposite over hypotenuse, so 18 over x. And with a little cross multiplication algebra, I know that to find x, I have to do 1 times 18 divided by the sine of 24. So that's just 18 divided by the sine of 24, which is 44.25. All right, let's move on to the next one. Here's my reference angle, 25 degrees again. I have the hypotenuse right here, and this is the adjacent leg to my angle. So I'm going to be using the cosine function. Cosine of 25 is equal to the adjacent side over the hypotenuse. So x over 16.6. This one's a little easier. All I have to do is multiply both sides by 16.6. So cosine of 25 times 16.6. I get 15.04. Last example, here's my reference angle, 38 degrees. I have the opposite leg and the adjacent leg. So I'm going to use my tangent function, which doesn't use the hypotenuse. So the tangent of 38 equals x over 13, opposite over adjacent. And again, all I have to do is multiply both sides by 13, and then I will get my answer. So the tangent of 38 times 13, I get 10.16. Okay, so that's just a little recap on how to use sine, cosine, and tangent to find a missing side length. Now, if we know the sides of a triangle, but we don't know the angle, we can use the inverse of these trigonometry functions. And luckily, they're provided for us in our calculators. So the inverse sine function, the inverse cosine function, and the inverse tangent function. So let's see how these work. The initial setup is the same. So for our example A here, here's our reference angle x, and we know the opposite side and the hypotenuse. So I'm going to use my sine function. So the sine of x equals 22 over 41. But now I don't know what my angle is. but I do know the ratio of opposite to hypotenuse. I have those numbers. So what I can do is use the inverse function of that ratio, 22 over 41. And that will give me my value of x. That'll give me that reference angle. So on the calculator, the way we would do that, first we'll find 22 over 41, and then we'll do the inverse sine function. On this calculator, it's found by pressing this second key, and then my sine minus 1 or inverse sine function here. And that gives me 32.45. So that reference angle, that x degrees, is 32.45. So very similar setup, just a slightly different button push on the calculator. For example, B, here's my reference angle. I don't know it. I have the hypotenuse here, and I have my adjacent side is 13. So I'm going to use my cosine function. And I know that the cosine of x is equal to 13 over 16, adjacent over hypotenuse. But since I don't know the angle, I have to use the inverse function of 13 over 16, and that will give me that angle. So 13/16 is 0.8125. I'll do my second cosine, the inverse cosine function, 35.66. And now this works because every right triangle, no matter the side lengths, because they are all in this unit circle, every right triangle has the same ratio using sine or cosine of these side lengths. So that's why we can use this calculator. No matter what the side lengths are, we can use the same function. Last one here, looks like we have the adjacent side and the opposite side to my reference angle. So I'll be using tangent. And the tangent of x is 54 over 44. The opposite side over the adjacent side, right? That's that TOA part, way up here. Okay, so let's use our inverse tangent function. Tangent minus 1 of 54 over 44. And we'll use that to find x. So 54/44 is 1.227272, and so on. I'll do my inverse tangent function. Notice there's these other ones, cosecant, secant, cotangent. Don't worry about those. We're just going to use sine, cosine, and tangent for now. 50.83. So there you have it. That's using the inverse of our trigonometry functions to find the angle when we know the two sides that we need, but we don't know the reference angle. We can use the inverse trigonometry functions here to find those angles.